In this lesson, we'll look at infinite limits. And so we've seen for several years graphs like this. And we know that there's a vertical asymptote at x equals 0. That occurs when we have a number that's not 0 divided by 0. We know there's a vertical asymptote. So all we're going to do now is just describe it using limits. The limit as x goes to 0 from the right is positive infinity. From the right, the graph goes to positive infinity. And from the left, it goes to negative infinity. All right, find the vertical asymptote and the limits on either side of the vertical asymptote. Let's look at this graphically, numerically, and analytically. And we want to know, when does f of x equal a number over 0? We want to know when the denominator is 0. So let's check. So the denominator is 0, and we have to see, it's obvious in this one because the numerator is never 0, but we'll substitute a 2, 4 over 2 minus 2, and we get 4 over 0. So we know there's a vertical asymptote at x equals 2. Just by knowing that there's a vertical asymptote, we have to check points on either side to see what the limits are. So when we look at the graph, there's a vertical asymptote at 2. And if we just graphed it on a calculator or Desmos, we'd see that. And that allows us to see the limit from the right is positive infinity. From the left is negative infinity. So we can answer the question about limits using the graph. We could also look at a table. Let's get points close to 2 from the left, from the right. And we know that that is undefined. Negative 4,000. This is negative 4 times 10 to the 6th. 4 times 10 to the 6th, 4,000. And from the right, we see that these y values are increasing, so we'll say that's going to positive infinity. These are going to negative infinity. And the limit as x goes to 2 from the right is positive infinity. The limit as x goes to 2 from the left is negative infinity. Let's look at a similar problem. Not that. Find the vertical asymptote pause the video and try that one. Make sure you do it graphically, numerically, and analytically. Alright, we want to know, when does f of x equal a number over 0? So that means we need to know when the denominator is 0. We should check each of those. F of negative 2 is negative 4 times negative 2, and then we have negative 2 squared minus 4. That's going to be 8 over 0. So we have a vertical asymptote at negative 2. Well, let's also check f of 2. If we put a 2 there, we have a negative 8. And 2 down there will give us 0. So that means we have vertical asymptotes at x equals negative 2 and x equals 2. So let's look at the graph. And we can describe the limits here. Limit as x goes to negative 2 from the left. To negative 2 from the left is positive infinity. Negative 2 from the right. Go to negative 2 from the right, that's negative infinity. Positive 2 from the right, go to positive 2 from the right is negative infinity. Go to positive 2 from the left. From the left is positive infinity. And we can check it numerically. Negative 2, let's just check one value to the left, one value to the right. Negative 2 is undefined, and here we have negative 199, and this is 200.5, so it looks like this could be going to negative infinity and that could be going to positive infinity. So we see that at negative 2, positive infinity, and negative infinity. And we can check the same way for positive 2. Now we just have to evaluate a limit instead of talking about asymptotes, even though there will be an asymptote if the limit is infinity or negative infinity. Let's think about this graphically, numerically, and analytically. All right, we have 2 plus 1. We know that's going to be 3, but now we have a 0 in the denominator. Should we say that this is positive infinity or negative infinity? And we can check just by putting a, let's put a 1.1 right here. We go from the right, 1.1, this will be negative, this will be positive. So we know it's going to be positive divided by a negative. And that's pretty much we're solving it numerically, because in the table we would look at, let's see what's happening at 1 from the right, so we don't care about this, and we can put in these values, negative 301, negative 31, and undefined. So from the right, it looks like these are going to negative infinity. This has a horizontal asymptote at negative 1, so that's from Algebra 2 and Pre-Calculus. We talked about horizontal asymptotes. We'll see it more in the next lesson. We can also find the X-Intercept if y equals 0. We want the numerator to be 0, so that's going to happen at negative 2. The y-intercept should be at positive 2, which I guess I could stretch the scale a little bit. The y-intercept is at positive 2, and the graph would look like that. We see from the right, the graph is going to negative infinity. And try this one. If you get stuck on evaluating it analytically, you can always make a table or make a graph and then work your way through the different representations. Pause the video and try that one. Okay, so what's happening at negative 1/2? We substitute that, and it's going to be 6 negative 1/2 squared plus negative 1/2 minus 1, 4 negative half squared minus 4 times negative 1/2 minus 3, and this equals 0 over 0. So what's happening at negative 1/2? We know that this is an indeterminate form, and we're going to have just an open circle on the graph. So the limit is not going to be infinity for this. Turns out there is a vertical asymptote at 1.5. And we could find that by setting the denominator equal to 0 like we did in the beginning. There's a horizontal asymptote at 6 over 4 or 3 over 2. And the open circle occurs at negative 1/2. So if we have the y-intercept is when x is 0, so that's going to be at 1/3. We have a y-intercept at 1/3, and the graph is going like this. At negative 1/2, somewhere around here, there'll be an open circle. we can find the limit numerically. So let's see what's happening at negative 1/2. We have to get close to negative 1/2 from the right, so negative 0.49. This is undefined, and then here we have 0.621. Well, that's hard to tell what it's getting close to. Maybe it's getting close to 0.62. So we also have a strategy from a couple lessons ago. When it's indeterminate, we may be able to cancel, and then we can just evaluate without the table. So if we cancel, we're going to factor the numerator. And factor the denominator. Now if we substitute negative 1/2, 3 times negative 1/2, 2 times negative 1/2, and we get negative 5/2 divided by negative 4.625. Alright, pause the video and try this one. We could just substitute a 0. We have 6 minus 1/0. We know that's undefined. But to make it look more familiar, why don't we get a common denominator? And this would be 6x cubed over x cubed. X cubed minus 1 over x cubed. And now we see that it's negative 1/0. If we substitute a 0, we get negative 1/0. So we know there's going to be a vertical asymptote at 0. We also have a horizontal asymptote at 6. And the x-intercept, by looking at this, we want to know when the y equals 0. So when does this equal 0? We'll have some small fraction. I'm just going to estimate where that is. And we can also look at the limit. We don't know from this, we can't tell what's happening until we check on either side of the 0. So we're coming from the right, so let's check a positive number right here, like 0.1. Put a 0.1 there and we get a positive. If we have a 0.1 there, we'll have a positive. But we should have, no, if you have 0.1 there, we'll have a negative. And then we get a negative y value. So we're going to say that's negative infinity. And if we check the table, we would put 0 and then check numbers to the right. And we should have negative number, large negative number here because the graph is going to negative infinity. And we can say the limit as x goes to 0 from the right equals negative infinity. All right, and we'll stop there.